Hi, and welcome to this week's live session. This one is due by 10 p.m. on Thursday, September 26th, 2013. I'm going to walk you through a bunch of slides. There are going to be questions on the slides. Some of the questions I will actually verbally answer, and some of the questions I will say for number 1, 2, 3, 4, you will need to submit those questions, or I should say answers to those questions, as your assignment. The focus of tonight's lesson is minerals. There are 5 key things that must be met in order for a mineral to be a mineral. Number 1, you need set atomic structure. It means the atoms need to be arranged in a pattern. Number 2 is set chemical composition. You need to have set chemicals, and that's it. Set chemical formula. Number 3, it must be solid. Number 4, it must be inorganic, which means it is not living, was not living, will not be living. And number 5, it must be naturally occurring, so it cannot be man-made. There are 8 key tests that can be utilized to identify a mineral. They are color, cleavage and fracture, hardness, luster, streak, crystal form, specific gravity, and special properties. And these 8 are going to be the basis for the questions of your live session. Question number 1. If you look at this picture, you can see that there are 5 different samples of minerals. They are all calcite. Please tell me why you think color is the least reliable test to identify a mineral. That's question number 1. Cleavage and fracture both describe the way a mineral breaks. Down below, in the second picture, that's actually called a conchoidal fracture, which makes sense because it is shell-like, and if you think of a conch shell, it's a shell. So that is called a conchoidal fracture. The major difference between cleavage and fracture is the way that a mineral breaks. In other words, cleavage is a nice, clean break at nice set angles or along a flat plane. Fracture is jagged. If you would please, for question number 2, in that top picture up there, tell me if that is cleavage or fracture that you are seeing for that mineral called mica. Hardness is the resistance to being scratched. You can use different things like pennies, nails, fingernails, glass, things like that. If you would please notice that in this picture, you've got a rating of 1 to 10. Talc is the softest and diamond is the hardest. For question number 3, please tell me the name of the mineral hardness scale. You will need to look that up. Give you a hint. It's a man's last name. Starts with an M. That's question number 3. Luster is defined as the way a mineral reflects light. You've got 2 main types, metallic and non-metallic luster. Metallic means it's shiny like a piece of polished metal. Non-metallic means it's not shining like a piece of polished metal. It can still be shiny, maybe like glass or a diamond, but not like polished metal. Streak is the true color of a mineral. It is the color of a mineral in powdered form. We use a white unglazed porcelain plate to test the streak. If you look at this mineral on the left, look at the color of the streak on the plate. That is the one on the left. For question number 4, please tell me the color of the streak of that mineral. Not crystal number 5. Question number 5 is going to come from this page. This is called crystal form. A lot of minerals grow naturally in certain shapes. For instance, Halite, which is rock salt, naturally grows at 90-degree angles. So does galena. If you would please tell me any one other mineral that grows in some sort of crystalline shape and tell me what that shape is. That is question number 5. Specific gravity is similar to density. One of the reasons why it's important is because certain minerals can look like other minerals, but if we take the specific gravity of them, we notice that they're different. One of those differences would be between gold and fool's gold. Gold is much more dense or has a higher specific gravity than fool's gold does. For question number 6, please research and tell me what is the true mineral name of fool's gold. Last but not least is special properties. There are many different special properties of minerals. This picture is actually showing you one of the special properties of minerals. If you would please find out at least one special property that any mineral contains or possesses. That is for the last question. If you would please remember to submit your answers by 10 p.m. on Thursday, September 26th, I would appreciate it. Hope you have a good night.